Today we are going to the next topic, that is latitudes and longitudes. So in your childhood, in your social subject, you might have studied about this, what are these longitudes and as well as latitudes. So now let us try to discuss this topic in very great detail, and you might have forgotten this topic like latitudes and as well as longitudes. So let us recall whatever you studied in your childhood. So first of all, why we need to talk about is latitudes and longitudes. So one question that will comes into your mind. So if you want to understand entire climatology, so you need to know what are these latitudes and longitudes. So unless and until you know what are these latitudes and longitudes basics, you can't understand climate, climatology part. That is especially weather patterns, winds, everything. So as you all know, these latitudes and longitudes, they are imaginary lines. So these latitudes and longitudes, they are imaginary lines. And why we are using these latitudes and longitudes? Especially to determine certain location of a place on the earth. Mainly to locate a place on the earth, we are using these imaginary lines. They are our latitudes and longitudes. As you all know, what is the shape of earth? That is geoid shape, means here towards poles will be having flatted, and its center it is mainly bulging like this. So this is shape of our earth, right? So this is geoid shape. So what happens if we are not using these imaginary lines called as latitudes and as well as longitudes? We don't know exact location of a place. So these are imaginary lines, and we are using these imaginary lines mainly to determine location of a place on the earth. So this is some introduction. And now let us try to discuss what is this latitude. So latitude means nothing but they are imaginary lines. They will be drawn horizontally. So like this way we are mainly drawing lines. So these latitudes are angular distance from a point. So what is meaning of this angular distance? Ma'am is saying angular distance. What is angular distance means? So first you have to draw circle, and this is center point, right? So from center point we are taking angles, okay? So here let us take 1 degree or 25 degrees and 60 degrees, 90 degrees. So in this way we are mainly pointing angles from center of our earth. And here also we are doing same 1 degree, and we are joining this 2 points. This is our latitude. And here if you see, this is our 60 degrees and here it is 60 degrees. So we are joining this. So in this way we are mainly drawing our latitudes. So because of this, these latitudes, they are angular distance of a point on the earth's surface. They are angular distance of a point on the earth's surface, and they measured in degrees from center of our earth. Now you will get some clarity. I think you got some clarity regarding how these latitudes are drawn. Okay, and if you are talking about these lines, so these latitudes mainly run horizontally. So these lines run horizontally. And equator, it is our 0 degrees latitude. So which is our 0 degree latitude? That is our equator. So from equator, okay, this is our center point, and we are mainly measuring angles, and we are joining those angles. So in this way we are drawing our latitudes. So lines of latitudes locate places north or south of the equator. So if you are taking globe, and this is our equator, let us take this as equator. So above equator it is called our northern hemisphere, and below equator it is called as our southern hemisphere. So what is northern hemisphere? So this equator is a dividing line. Equator mainly divides our globe into 2 halves. Upper part above equator is called as northern hemisphere, and below this equator is called as southern hemisphere. So this part will be our northern hemisphere, and below this equator is our southern hemisphere. If you are talking about how many latitudes are present, so here we have our equator. So above equator we are having 90 latitudes and below equator we are having 90 latitudes. Total 180 latitudes plus 1 equator. Total we are having 181 latitudes are present. So this is important prelims bit. And next one is their lengths are not equal. Why? Because our earth which is having zooid shape. So it is mainly bulged at center. So at center we are having long latitudes, and if you move towards equator they are short. So we are not having latitudes which are of equal length. So this is also one prelims fact. And one important thing you need to remember here is distance between any two parallels of latitude is always same. So if you are having one latitude here and if you are having one latitude here and here one latitude. So what is the difference between or distance between these two latitudes will be always equal. And next one is equator. Equator is our longest latitude. It is 0 degrees latitude. Right? And if you see from 0 degrees, if you are moving towards our 90 degrees and here 90 degrees. So this 90 degrees it is our north pole and this 90 degrees it is our south pole. So this is our north pole and this is our south pole. So 90 degrees north latitude. So 90 degrees north latitude mainly marks north pole and 90 degrees south latitude marks south pole. So if you see this image it will be very clear. So these are our latitudes, okay. So this is our equator, it is 0 degrees latitude and here we have 30 degrees north latitude, 60 degrees north latitude and here 90 degrees north latitude, it is our north pole. And here we have our south pole. South pole it is our 90 degrees south latitude. So this is the image, then you can easily remember this. And this image mainly shows how we are drawing this latitudes. So here we have 0 degree, it is our equator. So from equator, if you are drawing 50 degrees here, 15 degrees here, and if you are joining this, this is our 15 degrees north latitude. In the same way, it is 15 degrees towards south of equator and here 50 degrees. So if you are joining this, so this is our 15 degrees south latitude, it is our 15 degrees north latitude. And here 30 degrees north, okay, and here 30 degrees north. And if you are joining these two, it is our 30 degrees north latitude. In the same way, 30 degrees south and 30 degrees south, and if you are joining, so this is our 30 degrees south latitude. So here we are having north pole and here we are having south pole. So in this way we draw this latitudes. And now let us try to talk about which are the important parallels. So why these latitudes are called as parallel? Because they are parallel to each other, they are not going to meet anywhere. So this is one important fact again. So these latitudes, they will not meet at any place. They are parallel to each other, they are parallel circles. So they are called as parallels. So besides the equator 0 degrees latitude, we are having 90 degrees north, that is north pole, and south, that is south pole, 90 degrees south, that is south pole. Apart from that, you need to remember 4 important parallels. That is our Tropic of Cancer. In earlier lecture we studied about sun rays will fall directly on this Tropic of Cancer in this summer solstice. In winter solstice, sun rays will fall directly on this Tropic of Capricorn. So here you need to remember this Tropic of Capricorn and as well as Tropic of Cancer. So these Tropic of Cancer is 23.5 north latitude and Tropic of Capricorn is 23.5 degrees south latitude. Okay, and other 2 important parallels is Arctic Circle. Arctic Circle, it is at 66.5 north. Okay, 66.5 degree north. And next one is Antarctic Circle, which is at 66.5 degree south. So these are 4 important parallels. So you need to remember equator, you need to remember Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle, North Pole and South Pole. Let us have a look over diagram. So these are the important parallels. So here we have North Pole, here we have our south pole. So this is our equator, which is 0 degrees, and this is our 25.5 degrees north, that is Tropic of Cancer. 25.5 degrees south, it is Tropic of Capricorn. 66.5 north, it is Arctic Circle. 66.5 south is Antarctic Circle. So these are important parallels. So if you see across the world, so here equator is our 0 degrees latitude, and next one is 30 degrees north. Okay, normally whenever we are studying this climatology, we will not refer 22.5 exactly, but we will say like 30 degrees north and 30 degrees south. So that thing mainly given in this diagram as well. So 30 degrees north, okay, here we can see Tropic of Cancer, okay, which is below this 30 degrees north, and here we are having this Tropic of Capricorn, which is below this 30 degrees south, and here we have Antarctic Circle and as well as Arctic Circle, and here we have North Pole and South Pole. So here there is a tilted axis, right? So here we have South Pole and here we have North Pole and here we have South Pole. So now let us try to talk about heat zones of the Earth. So there are 3 important heat zones of the Earth. First one is tropical zone, or we can say torrid zone. Second one is temperate zone, and third one is frigid zone or polar zone. So we are talking about torrid zone or tropical zone, which is mainly present between Tropic of Cancer. It is present between Tropic of Cancer and Tropic of Capricorn. It is present between Tropic of Cancer and Tropic of Capricorn. So why? Because this area will receive highest amount of heat from sun. Okay, so here we can see for 6 months sun will be in northern hemisphere, right? That is Uttarayan and Dakshinayan. So in this Uttarayan, sun will be mainly Tropic of Cancer will be getting direct sun rays from sun, and in this Dakshinayan, Tropic of Capricorn mainly receives direct sun rays from sun. So because of this, this zone which mainly receives high amount of heat from sun, so this area is called as tropical zone or torrid zone, which receives maximum heat. And this one is temperate zones. So in this temperate zones, here these zones will not get direct sun rays, they will be getting slanting rays. Okay, so it is mainly beyond Tropic of Cancer and between this Arctic Circle, and if you see in southern hemisphere, it is between Tropic of Capricorn and Antarctic Circle. So here we can see moderate temperature because of slanting rays. And next one is frigid zone. So these areas which are lying above Arctic Circle in northern hemisphere, and it is lying above Antarctic Circle in southern hemisphere, and these regions are very, very cold, and mostly these are covered by ice caps. So these are 3 important heat zones of Earth. So if you see this image, you can easily understand. So this is our tropical zone, that is between Tropic of Cancer and Tropic of Capricorn. It is also called as torrid zone or tropical zone. And temperate zone, which is present between Tropic of Cancer and Arctic Circle in northern hemisphere. In southern hemisphere, between Tropic of Capricorn and Antarctic Circle. So beyond this, beyond this Arctic Circle until North Pole, it comes under frigid zone or polar zone. And here beyond this Antarctic Circle until South Pole, it is also called as polar zone or frigid zone. So these are 3 important heat zones of Earth. So if you see these heat zones, then only we can identify which are the low pressure areas and where we can see high pressure areas. So these topics that will come in our climatology portion. So now let us try to see one more image. It is also regarding this. So if you see here, sun is present. So here this area will get direct rays from sun. Here there will be slanting rays. So because of this, this region will be getting high amount of sunlight or intense heat or maximum heat, and this area will get moderate heat, and this area will get very, very less amount of heat. So this is also one image. You can also draw this type of image in your mains. So this is our torrid zone, between Tropic of Cancer and Tropic of Capricorn. And here we have North Temperate Zone between Tropic of Cancer and Arctic Circle. And here we have South Temperate Zone between Tropic of Cancer and Antarctic Circle. And here we have Frigid Zone between Arctic Circle and North Pole. And here Antarctic Circle and here till South Pole we have Frigid Zone. So these are three important heat zones. Now let us talk about next part, that is our longitudes. So these are also imaginary lines, but there is difference between longitudes and latitudes. So these longitudes, they are vertical lines. Okay, they mainly joins this north and as well as south pole. They will be moving in this way. So they are meeting, they are not parallels, they are meeting at north pole and as well as south pole. So because of this, at center there is white and towards pole they will come together. So but if you see latitudes, so they will be having equal distance anywhere, but it is not the case in this longitudes. Longitudes, they will merge together at north pole and as well as south pole. So this longitudes will be somewhat tricky than compared to that of latitudes. Latitudes is very easy, but these longitudes, so you will come across some important concepts in this longitudes. And if you focus only, you can understand those concepts. So I will try my level best to make you understand those concepts. So first let us try to see longitudes. So if you are drawing only latitudes and if you want to try, if you are trying to locate exact place, is it possible? So you can say it is mainly present on equator, but on equator where exactly? So here if you also drawing this longitudes, then only you can understand. On equator at 5 degrees east longitude or 5 degrees west longitude, that place is located. So in this way you can easily locate exact location. Without longitudes, if you are drawing only latitudes, it is waste of your time. So without latitudes, if you are drawing only longitudes to identify the place, it is also your waste of time. Both these latitudes and longitudes, they will help to locate place exactly. Okay, so if you see here, these longitudes, they mainly runs vertically. Latitudes mainly runs horizontally, but these longitudes mainly runs vertically. Okay, these are vertical imaginary lines. So these lines, they are also called as meridians. Okay, these lines are also called as meridians, and the distance between these longitudes measured in degrees of longitude. So if you are talking about Earth, okay, Earth is like a spherical shape, so it will be having 360 degrees, right? So these 360 degrees mainly divided into minutes, and these minutes will be divided into further seconds. So if you are talking about longitudes, for example, if you are talking about latitude, we are taking one imaginary line, it is called as equator, and above this is called as northern hemisphere, and below it is called as southern hemisphere. So can we apply this same thing in longitude? No, we can't, because every longitude is identical. But if you see in longitudes, if you see in here in latitudes, so equator is the longest latitude, but if you are moving towards pole, size is decreasing. But here longitudes, they are all of same size. So this is the problem that we are facing regarding this naming of this longitudes. So finally, what we did here is we came up with this 0 degrees longitude. So all these longitudes, they are equal in length, and therefore it is very difficult to number these meridians. So finally they came up, geologists, they came up with a decision to begin meridian that mainly passes through this Greenwich. Okay, so they started with this 0 degree longitude that mainly passes through this Greenwich, where British Royal Observatory is located. Okay, it is called as prime meridian or 0 degree longitude. Okay, they started numbering of this longitude. So we are having 360 degrees, right? So every degree they started drawing one line. So first one is 0 degrees longitude, and they started drawing other longitudes. So for example, this is east part, this is west, right? So To the east of this longitude, they have 180 degrees, like 180 longitudes, and to the west 180. So these 180 west and 180 east will be same line. Totally how many longitudes are present? So from here 1 to 179 east, and here 1 degrees west to 179 west. That means 179 west longitudes are present, 179 east longitudes are present, and one is 180, okay, and next one is 0 degrees. So totally we have 360, okay, totally we have 360 longitudes. Latitudes will be 181, here longitudes will be 360. And if you are talking about this 0 degree longitude towards east, okay, so this 0 degree longitude will divide our earth into two parts, two equal parts, okay, eastern part and as well as western part, right? So because of this, whenever we are drawing longitudes towards east of the 0 degree, they will have this east, okay, 1 degree east, 25 degree east, 82.5 degree east, like that. And longitudes which are coming towards west of the 0 degrees, they will be having 1 degree west or 75 degrees west longitude, like that. Okay, so this longitude which mainly divides earth into two equal halves. So eastern hemisphere and as well as western hemisphere. So in latitudes, here 0 degree equator, the 0 degree latitude, that is equator, will divides our earth into two halves, that is northern hemisphere and the southern hemisphere. So in the same way here 0 degrees longitude divide earth into two hemispheres, eastern hemisphere and as well as western hemisphere. And now let us try to talk about longitude and time. So earth divided into 24 time zones, that means 1 hour each zone. Okay, so earth it is divided into 24 hours because for the complete rotation of earth it will take 24 hours. So earth which is mainly divided into 24 time zones. So already we are having 360 longitudes. So if you are dividing for every 1 hour, so how many you will get? Like it will cover for 1 hour, it will be like 15 longitudes. Okay, 1 hour will have 60 minutes, right? So 60 minutes will cover 15 longitudes. So for one longitude it will mainly takes 4 minutes. So earth to move one longitude, it will take 4 minutes. So this is the thing, okay, you need to remember, and in this way we can calculate time. So if you are talking about this is our 0 degree longitude, let us take this as our 0 degree longitude. So at this 0 degree longitude, sun it is at highest position in the sky. That means let us take here it is 12 noon is happening. So if you want to calculate time which is ahead of this 0 degree longitude, means I can say like 5 degrees east longitude. So at this 5 degrees east longitude, what is the time? So here it is 5 degrees ahead, means 5 into 4 minutes, that is 20 minutes. So if you want to calculate time at 5 degrees west longitude, means here it is 12 exactly means, okay, here 12 exactly means here 1 degree is equal to 4 minutes. So 5 degrees is equal to 20 minutes. So here we can see time, that is 11:20, and here at this 5 degree east, that will be 12:20, okay, 12:20 p.m. here 11:20 a.m. So in this way you can easily calculate time. It is a very easy thing. So as you all know, earth which is mainly rotates from west to east. So east part, okay, east longitudes will have time ahead compared to that of this 0 degrees, that is Greenwich longitude. So if you are seeing the time, if you are comparing the time in our western hemisphere with this Greenwich longitude, means it will falls behind. So here east will be ahead and west will be behind because of rotation of our earth from west to east. Okay, and now let us try to calculate the rate of difference. So if you are talking about 360 degrees, okay, 360 degrees, that should be covered in 24 hours because one rotation will take 24 hours. That means here For every 1 hour it will cover 15 degrees. So for 1 degree it is about 4 minutes. We did this calculation, right? So if you want to calculate time, I gave you an example. So at this 0 degree longitude, this Greenwich time, it is exact 12. So if you want to calculate time, that is at 15 degrees east, means time will be ahead of this 12, right? So 15 into 4, that is 60 minutes, that means 1 hour. So here at this 15 degrees east, time will be 1 p.m., 1 hour ahead of this 0 degree longitude. And if you want to calculate time at 15 degrees west, time will be behind, right? So it will be less than 12. So if you are calculating east longitudes, time will be more compared to that of this 0 degrees longitude. And if you are comparing with this west longitudes, means time will be below, right? So here 15 degrees means 1 hour. So 1 hour less to this 12, that means we can see here it will be 11 a.m. So in this way you can calculate time. So if you are talking about these longitudes, here we have this 0 degrees longitude, and from here these will be our east longitudes. So here we have India. So in India, what is standard time? That is 82.5 east longitude, right? Standard time we will follow here is 82.5 east. So if you calculate from 0 degrees to 82.5 degrees, it will be like 5.5 hours. So if you are comparing with the 0 degree longitude, the time, okay, we are ahead of 5.5 hours. So here this will comes under our west longitudes, right? So here west, 180 degrees west and 180 degrees east is same longitude actually. So now let us try to talk about standard time and time zones. So this is also one important subtopic that you need to remember. So if each town they were to keep same time on its own meridian, there would be much difference in local time between one town to another time. So if you want to come up with one standard time, means it is not suitable actually. So here, for example, if one town which is mainly following one time and another town which is following another time, or another time which is followed in another town, means, so if any traveler, if I want to travel from one place to another place, so whenever I am moving in my journey, I need to set my watch. So this is the thing I should do in my whole journey. Whenever I am passing from one town to another time, I need to set my watch. But this is very, very inconvenient, and as well as practically it is impossible actually. So because of this, to avoid these difficulties, we came up with a system of standard time. Standard time which is present in all countries. In India, it is about 82.5 degree east longitude. We follow that time. So most of the countries, they adopt their standard time from the central meridian of their country. So if you see, this is the country and this is a central meridian, central longitude. So this time they will follow. So this is a standard time of that country. But if you see, there is also one problem here. Some countries, they will be having largest expansion from east to west or west to east. So in that country, they can't go for only one standard meridian. So in that time, that country which is having larger geographical area which is spreading from east to west, so they will follow different time zones. Okay, they will go for different time zones. For example, countries like Canada, USA, China and USSR, they will have different time zones. They will be having number of time zones. They will be not follow only single time zone. They will be having multiple time zones. For example, if you see Canada, which is having 6 time zones. For example, Atlantic time zone, Eastern, Central, Mountain, Pacific, Newfoundland time zone. So the time difference between here, this is Atlantic time zone, here Pacific time zone. So there is a large difference between these two time zones. It is about 4 hours. Okay, it is about 4 hours. So this is the image I took, especially from this Canada website. And so I found it is very helpful, and this will be helpful to understand, right? So here we are having 6 time zones. That is here one time zone, Newfoundland time zone, here Atlantic time zone, here Eastern time zone, Central Daylight time zone, and here we have Mountain Daylight time zone and Pacific Daylight time zone. So these are the different time zones which are present in Canada. And if you're talking about Russia at present there are about 11 time zones. Okay, so these are the colors which mainly saying about this time zones. So these time zones will be changed, okay, changed by time over period of time. So you have to be updated with this different time zones. So till now there is no question regarding this time zones which ask like, so which country is having how many time zones, but you have to know an idea like, so every country will not follow only single standard meridian. So they will be having different time zones. For example, countries, they will be having large geographical expansion from east to west, right? And now let us try to know some important facts regarding this international dateline. So if you're talking about this Greenwich Mean Time, that is our 0 degree longitude, it is a time which mainly measured on our Earth's 0 degrees line of longitude or meridian. So what is this Greenwich Mean Time? That is GMT. You will come across this word, that is GMT. GMT is nothing but what is the time that we are calculating at this 0 degrees longitude, that is Greenwich meridian. So at this Greenwich meridian, whatever the time we are calculating, so this time is called as Greenwich Mean Time. So this mainly runs from North Pole to South Pole. So this already we know that this 0 degree longitude which mainly passes through Royal Observatory in London. So this line is called as Greenwich line since 1884 onwards. Now let us talk about international dateline. So till now we studied about this 0 degrees longitude, that is our Greenwich longitude. Now we need to study about this international dateline. So I want to give you a small information. So this international dateline, it is nothing but our 180 degrees longitude. So let us take help of my ball again. So I will show you from near. So this is, let us try to see, this is our 0 degrees. Okay, so this is our 0 degrees longitude, exactly to this opposite side. Okay, so if this is our 0 degrees, and exactly to this opposite side we will be having our 180 degrees longitude. Okay, so if this is 0 degrees longitude, and exactly to opposite side we will be having our 180 degrees longitude. So to understand this international dateline, we need to know about 0 degrees longitude and as well as 180 degrees longitude. So till now what we discussed? Till now we discussed this is our 0 degrees longitude. So when we are moving towards east means time we have to add, and if we are moving towards west means time we have to subtract. Till now is it clear? And now let us try to see what is this 180 degrees. So this 0 degrees mainly dividing our earth into two hemispheres. This is our eastern hemisphere and this is our western hemisphere. So this is according to our 0 degrees longitude. And if you are talking about this 180 degrees longitude, it will be opposite, right? So if you are at 0 degrees, this will be your east and this will be your west. And if you go here, the priorities will be changing, right? So here eastern hemisphere. So if you are talking about this 180 degrees, okay, so if you are talking about this 180 degrees longitude, so this is your east of it and this is your west. So to your west, if you are talking about to your west, you will be have opposite things, right? So at 0 degrees to east you will be having eastern hemisphere, and to your 0 degrees west you will be having western hemisphere. So if you are talking about here 180 degrees, here towards your west you will be having western hemisphere, and towards your west of this 180 degrees you will be having eastern hemisphere. So this is the thing that you need to be clear. And if you want to move from east to west, okay, so if you want to move from east to west here, so if you are moving from east to west, you are going to lose a day. Okay, from eastern, okay, from east to west you will be going to lose a day. So this is according to your international dateline. So if you see, if you are comparing with here means, so if you are going from east, okay, from east to west you are going to subtract time. So this is international dateline. So in this international dateline, whenever you are moving from east to west you are losing a day, and whenever you are moving from west to east you are going to gain a day. So if you are talking about whenever any person, okay, whenever if a person move from west to east along this international date line, okay, I am saying west to east. So in this way, whenever any person who is moving from west to east along this international date line, he would gain a day. And whenever any person who is moved from east to west along this international date line, he would lose a day. So now let us try to see in a very clarity. So this is our international date line, that is 80 degrees, 180 degrees. So this is our west and this is our east. So in east we have western hemisphere and in west we have eastern hemisphere. For example, in western hemisphere, if it is, for example, let us take Wednesday. Okay, if it is Wednesday, okay, if it is Wednesday in western hemisphere, and eastern hemisphere it will be your Thursday, right? So in eastern hemisphere, okay, in eastern hemisphere it is Thursday and in western hemisphere it is Wednesday. And if you see here, in eastern hemisphere if it is Sunday and in western hemisphere it will be Monday, right? So if you are comparing with this 180 degrees with 0 degrees, it mainly says that, so here if you are seeing this 0 degrees, okay, 0 degrees longitude, here towards your east you will be having eastern hemisphere and towards your west you will be having western hemisphere. But in this 180 degrees, it is exactly opposite to this 0 degrees, right? So here priorities will be changed. So in CSAT, you will be practicing this type of questions, like if you are facing towards east, if you are facing towards north. So in this way, directions will be changed. So if it is exactly opposite here, so your west becomes east and your east becomes west, right? So if you are comparing with this international date line, so in your east side, it will be having western hemisphere and in western side, you will be having eastern hemisphere. So if you see here, from whenever we are moving from this line, that is our standard meridian, that is 0 degrees. If you are moving towards east, that means you will be adding time. Towards west means you will be subtracting time. So the same thing you can apply here. But here, whenever we are moving from eastern hemisphere to western hemisphere, then we are going to lose time, right? So here if it is Thursday, it will be next day, that is Wednesday here. And if it is Sunday here in western hemisphere, whenever we are moving towards eastern hemisphere, that will be Monday, right? So this is about this concept of this international date line. So let us try to understand what is written here. So if you see international date line, so this is nothing but dividing line between east and as well as west. Okay, east and west, GMT. So what is here GMT means? That is Greenwich Mean Time. So the time at our 0 degrees longitude, that is Greenwich longitude, that is called as Greenwich Mean Time, right? So whenever, if you are seeing this is Greenwich Mean Time, and if you are moving towards east, we need to add time, and if you are moving west, we need to subtract time. So this is our Greenwich Mean Time, that is plus and minus. Okay, plus we can see in east, okay, and west when we are moving means we need to subtract, that is GMT minus. So this date line which is present between this east and as well as west GMT. So whenever any traveler who is moving eastwards, mainly to gain time, okay, so this is our 180 degrees longitude, this is our east and this is our west, right? So whenever any traveler who is mainly going towards eastwards, okay, mainly going towards eastwards means he can mainly gain a day. That means from west they are moving to east. So in east we have Wednesday and here west we have Thursday. That means whenever we are moving from west to east means again we will be having Wednesday only. So in this way he can gain time. And whenever any traveler who is moving from east to west, from Sunday he is moving towards Monday. So he is losing one day. So this is the concept that you need to understand, and please try to make a note, then you can easily understand this. Why I am saying gaining a day, why I am saying losing a day. So let us take one more example by date. So here, for example, in West Hemisphere it is December 31st and in Eastern Hemisphere it is January 1st, right? So whenever you are moving from here west to east, means you are mainly skipping this one day, right? So you will be directly entering into January 1st. So you are mainly losing a day. So if you are moving from west to east, you will be gaining a day. You can celebrate that January 1st again, okay? So in this way, one thing I want to say here is, whenever you want to celebrate your birthday twice, so please go to this international dateline area. And if you are moving towards, if you are in east, you can celebrate birthday. After celebrating your birthday in east, you have to, okay, and you have to go here, okay? So in this way, international dateline, which mainly helps to identify the date, okay? So one important thing that you need to remember here is, a traveler whenever crossing this international dateline from east to west, he will lose a day, okay? From east to west, whenever he is moving, means he mainly loses a day. Whenever any traveler who is moving from west to east, means he gains a day because of gaining of time, right? So this is the thing that you need to remember. And if you see this international dateline, okay, so I have to explain this image first of all. So this is our east and this is our west and this is our international dateline, and here this side we will be having 0 degrees longitude, that is our Greenwich. Whenever you are moving from west to east, you will gain a day, and whenever you are moving from east to west, you will lose a day. So what is the thing which mainly we discussed here, right? And now let us try to see this international dateline. So this is international dateline, right? So it is not straight. Why? So here you can see there are many islands. So actually this international dateline mainly passes through our Pacific Ocean. So in Pacific Ocean we are having number of islands. For example, we are having Melanesia, Micronesia and as well as Polynesia. So these people who are present in this area, they will be moving here and there. So if at all it is a straight line, means, so if at all I am crossing this date line, means changing of date happens. So these people who are belonging to certain community and they are living together, means whenever they are moving here and there, that will leads to changing in the time, changing in the date actually. So because of this, we came up with this zigzag manner of this international dateline, okay? So for example, some groups of islands like Polynesia, Melanesia, Micronesia, they mainly fall on either of the dateline. So if the dateline it is straight, means two regions of the same island country, they will be having different dates, mainly to avoid this confusion. So if you say these islands are present like this, and dateline which is mainly moves in this way. So because of this, we can say zigzag. So you can see here we have Australia, you have Melanesia, Micronesia as well as Polynesia. They are a group of islands. So here dateline which is mainly moves in this direction. So this is about international dateline. So you have to remember this, okay? So this is our international dateline, this is our west side and this is our east. So in east we are having Western Hemisphere, and here towards our west we are having Eastern Hemisphere. Eastern longitudes are present here and Western longitudes are present here, right? So whenever we are moving from west towards east, okay, west towards east, so we mainly gains a day, okay, west towards east we mainly gains a day, and whenever we are moving towards, okay, east to west we mainly loses a day. So this is the thing that you need to remember, and please try to draw a diagram. So whatever the thing I drawn here, please try to draw this and you can easily understand the concept. So by this we are concluding today. I hope you enjoyed this lecture. Thank you so much.